My name is Hari Balasubramanian. I'm an associate professor of industrial engineering here in the Mechanical and Industrial Engineering Department. The industrial engineering program, we have a BS, a Bachelor of Science, a Master of Science, and a PhD.
Okay.
Industrial engineering is more broadly defined. You could think of it as a field that helps make systems operate more efficiently, much more effectively. A system is very broadly defined. It could be a healthcare system where you want to optimize or minimize wait times for a patient. It could be an airline trying to schedule its hundreds of flights in a day. It could be a transportation system in a particular region, state, or city. So a system in industrial engineering is broadly defined, and which is why in the modern day, industrial engineering is often also called systems engineering or industrial and systems engineering. So industrial engineering is a very interdisciplinary field. It borrows from many different disciplines such as mathematics, computer science, the algorithms of computer science. It also requires a bit of psychology and human factors because in the end, industrial engineers deal with these large complex systems which are usually, they involve people working with technology and so therefore an understanding of human factors and psychology also plays a role. So algorithms, mathematics, an understanding of probability theory, and a lot of the mathematics that engineers, all other engineering fields do also apply in industrial engineering in the management of these large-scale systems.
Okay.
So my main area of research is applying industrial engineering to improve the delivery of healthcare systems. This interest of mine started when I did a postdoctoral position at Mayo Clinic, a large academic institution in Minnesota. That was in 2006. So in the last 10 years, I've been working on how do you improve the delivery of healthcare, especially measures that are important for the individual or patient. Almost every one of us has had probably some experience with the healthcare system. For example, either we might have been to an emergency room, or somebody we know or some close family member might have been to an emergency room. And emergency rooms in the United States are experiencing a lot of delays. Some people have to wait 4 or 5 hours. Some wait times are even longer. So this is an example of a healthcare system where there's a lot of room for improvement in patient measures such as waiting time. So the type of work I do involves how do you schedule physicians, nurses, the shifts of these physicians and nurses to reduce waiting times. That would be one example. There are other examples on how do you get appointments with specialist doctors or primary care doctors so that you can avoid hospitalizations that cost a lot to the system and are also burdensome for the individual. Another example might be FedEx. You can imagine FedEx has to deliver its packages within a day, some in 2 days. So where should it locate its cargo planes? How many ground trucks should it have to deliver its parcels? So a lot of these requests for deliveries are uncertain. You might have more uncertain times of the day than others. So managing these uncertainties and making these deliveries, locating the hubs at the right places, these are all again decisions with which industrial engineers can help. So Professor Erin Baker, who is a faculty member, who's a professor here in industrial engineering, she has an energy decision-making lab. She works on different types of mathematical models to better invest in the right energy technologies. So if you're a government or a research and development agency that is helping the government and you have a certain amount of resources that you can invest in different types of energy technologies, there are some existing ones that can increase the amount of emissions and therefore have a significant negative impact on global warming. As opposed to this, you might have other technologies, renewable energy technologies, that may require greater investments, but then can significantly reduce the emissions.
Okay.
So industrial engineers then now have to decide what's the right portfolio of energy technologies a government or a research organization should recommend so that the economy is not affected as a whole, and yet emissions do not increase too much.
Okay.
So this, the aspect of human factors is probably one of the most crucial elements in industrial engineering. Every system in the world, or every technologically based system in the world, and the world is so much more technological these days, but in the end, the people who operate these technologies are humans, and we need to understand how people interact with these technologies, what kind of behaviors people have when presented with incentives. So an understanding of how humans interact with technology and human behavior, human psychology, is a crucial part of industrial engineering. And so in our program, we have 3 faculty members who actively pursue human factors in transportation engineering as well as healthcare. So industrial engineers also can play a role in understanding how diseases spread, the epidemiological spread of diseases in a population. We can model them using simulation. And in fact, some of the work that the group Doctors Without Borders did in trying to help understand the spread of Ebola and also how it spread in West Africa to other parts of the world. How do we contain the spread of those diseases? So that's another area where industrial engineers can help a lot. We have a faculty member, Chaitra Gopalappa, who recently joined us, who helps in understanding these infectious disease spreads with specific applications to HIV, Ebola, and she's also modeling the spread of cancer in different types of populations in the world. I would like to say that our graduates get jobs in a wide variety of fields. As you can see, the applications are pretty broad. We have students who've joined the banking industry, who've joined healthcare insurance as well as healthcare organizations. We have students who've joined Boeing and the aviation industry, manufacturing. The salaries for industrial engineers also tend to be very competitive. So I think if you're interested in systems as a whole and how large-scale systems function in the modern world, how connected they are and how they need to be coordinated to make them work efficiently, then industrial engineering could very well be the right major.